Well, what's important isn't the immediate flip of the sun. It's the fact that it's flipping means that the solar cycle is just about over. And if you take a look at this chart I sent in, this particular solar cycle is really going into the tank. It's half as strong as the last one. And there's a lot of studies that say that the next solar cycle is going to be down to next to nothing. In fact, very little sunspot activity. And that has implications as far as the weather goes. In testing this whole theory, is it the sun, oceans, and stochastic events versus CO2? You got to understand that we've had 200 years with high sunspot activity. Now, in the shorter term, a lot of times when you have the low geomagnetic field, you get a lot of blocking over the North Pole, and that implies a cold winter, and we're actually looking for a pretty cold winter in the United States. So that's something that we've seen before. But in the longer term, it may mean that the next sunspot cycle is really in the tank.
And Joe, just to follow up, link this to the whole global warming argument here. Is this a function or a cause of, or is this a contradiction to the fears that we're heating up too much?
Well, what we believe is, a lot of us believe that the sun, the oceans, and again, stochastic events, volcanoes, are the main overall climate drivers, and that CO2 is boxed in and can do very, very little, if not anything at all, against the entire climate. So we're getting, you guys got to understand that with the switch in the ocean cycles and the solar cycles, we're getting our tests now, so we should be able to get the answer. I don't know why these folks on the CO2 side of the argument are afraid of this test coming up, but we're going to see within the next 20 or 30 years. We've had 17 years of it leveling off. It's been starting down since the Pacific cooled, and there are people who believe it's going to be mighty, mighty chilly by the year 2030 after this next sunspot cycle, if it goes into the tank like that. So this is a fascinating thing for science.
Rain, black hole sun, won't you come, won't you come?
Whole new meaning on that song lyric, Black Hole Sun. Scientists at NASA have given us some amazing images, and they've discovered there's actually an enormous dark hole over our sun. Corey Powell's editor at large, Discover Magazine, here to look at these images. Nice to see you, Corey.
Yeah.
What is this?
Weather map on the sun. You'll notice part of the sun is missing. So this is a picture of the sun in ultraviolet rays. What you're seeing is this is 3.5 million degree plasma erupting from the surface of the sun. This part that's missing, the reason it's dark, is that whole chunk of the sun basically ripped off, blew out, and is coming our way at about 2 million miles an hour.
Our way.
Our way.
That doesn't sound good.
Well, I mean, this kind of thing happens all the time, but you don't very often see something that big. So I'm going to go all Carl Sagan on you here for a second. So this is about 80 times as wide as the Earth. If you're looking at the Earth on this scale, it's about that large. So this is an incredible chunk of the sun that's flying out. What happens when it hits our planet, it causes auroras, it wiggles the magnetic field. The thing you really worry about is it can disrupt your GPS, it can mess with your communication satellites, it can mess with your power lines.
Is that like a solar flare? Or?
So yeah, so these hot spots are where the things are really kind of intense and bubbling. This is where it's basically reached the point where it just kind of completely blew off. You're actually not seeing the hot gas here because it's no longer on the sun. It's coming into our face.
Did we ever know this before? Or did we not take note of it?
Well, we know it's really very recent that we've even been able to see these things, and so we kind of knew, there's this constant low-level thing, a few $1 million a year damages, more or less, just our solar satellites, power lines, things. We knew that the sun was messing with us, and we didn't exactly know why. now you see why. And the real worry is this is actually, believe it or not, this is a small one. This is a minor one.
Wow. Can you tell us what this means then?
So what this means is this is what the sun does all the time, and we don't really know why it does it. There's an 11-year cycle of solar activity, and right now we're going into a time of peak activity. And that's when all those things I was talking about before, you really need to watch for your power lines, your satellites, for all that.
But you just said something there. You said it happens all the time. If it happens all the time, is there a real risk to us? Or are we just noticing now?
Well, so there's two parts. I mean, there's the stuff like this. Like I said, this is actually not even a particularly bad one. So this is what happens all the time that we weren't really noticing, that now we're starting to understand and forecast. But there are much more intense ones. There was a giant solar flare in 1962, right before we really had a whole lot of satellites, an even bigger one in 1859. Wow. And if something like that happened again, that could cause a global blackout.
You always talk about, solar flares as the biggest danger on a large scale. So we will see. Corey, thank you. Excellent explanation.
Oh, well, thank you.
And we'll call you Carl Sagan next time, okay? Cool?
Yeah, millions and millions of Earths would fit in this picture.
Yeah, nice.
There you go.
Thank you.